I'm going to demonstrate how to use the Behave Unity plugin, which allows you to define AI behavior trees very quickly and very easily from within Unity. What you're looking at here is a project that already has Behave imported, and I've already created a library called the Wild West Behave library. AI trees are stored in libraries in Behave, and they're also stored within what are called collections. So you can define these different collections, perhaps for different agents or for different states, and each collection can have many trees in it. It allows you to organize your trees. So you can see I've already got a collection called Minor Behaviors and a tree called Daily Life Cycle, which is this one here. But I'm going to create a new tree just to show how easy it is. So here's our new tree, and I'm going to drag some nodes out onto the screen. And you can see not doing any coding here. There's no scripting involved. It's just a GUI editor, very simple. Anyone could do this who has a general understanding of AI behavior trees. And I'm just connecting these patch cords between the nodes. There you go, simple as that. I can take each of these actions and I can name them. So, I can call it whatever. Walk. Idle. So essentially each of those is going to define a different type of action that the agent could perform. And you can see there's different types of decision nodes that appear along the way. So a sequence node, for example, is going to try to call each of its children in order. So it's going to call this one first, and then it's going to call, after that one completes, it's going to call this one, and then it's going to call the final one. A sequence node is going to look for, a selector node is going to look for a single child to return true, after which it's going to stop. So if it has 3 children, then it's going to run the first one, and if it returns true, it's going to stop. Otherwise, it'll return the next one, and if it returns true, it'll stop. Otherwise, it'll keep going on down the list until it finds one that returns true. The priority selector allows you to define a function which determines which of its children are the priority at any given moment. So this is how you would define your evaluator functions, like the Raven bots use, to determine their top-level goals. And a parallel is going to let you actually run multiple actions simultaneously. So if you need your agents to be able to have multiple goals that are going on concurrently, this is how you would be able to do it using a parallel. You can see there's also this daily life cycle object, which is the same tree. It's the very tree that I defined over here. So I can actually take a tree that I've created and make it a subnode of another tree, which with these nested trees defines can let us define some very complicated AI behaviors very cheaply. You saw that was nothing. I created one tree and then I just dragged it into the second tree's list here. So it was very easy to make this this tree, and this one too. It's very quick. I'm going to show you the coding that has to go on behind. So once you've created the tree, you do actually have to compile it. So that is a bit of a pain sometimes. You can say I only have 2 trees and it took a couple moments. If I had a lot of trees, it might take a little longer. But it does compile the trees into this library build file, after which I can access them from my code. So here's the agent, the minor agent that we've defined here. It inherits from iAgent, and it needs to keep track of its tree. It needs to initialize its tree, and then it does what amounts to calling this tree.tick function every couple of frames. So you get to define how often it's called. It's the runtime library, or the behave library isn't defining it for you. You define how often you want to call it. But if you're calling it at regular intervals, then it'll work its magic. You need to define a function that's going to determine which of the goals are the priority at any given moment, if you have any behavior priority trees, any priority nodes in your tree. You also have to define one function for every action that you have in your tree. So those are called tick, and then the action name, and then the word action. And it'll just find the correct functions when it goes to call your class. So that's it. This is the whole minor class. It's 126 lines, and I made that tree in a couple of minutes. So let's go see what we do. Let's run it. Pull the console out so you can see it. And you can see, here's the miner, just like in the Buckland book, heading to the mine, picking up a nugget. So it's a very simple AI, very simple example, but you can see that it didn't take very long to define any of that. And you can imagine that this could simplify the process of creating even more complicated AI using even more complicated behavior trees.